Today we are going to learn Unit 22, Electrolysis. So at the beginning of the chapter, Electrochemistry, I mentioned that we are going to learn two kinds of reactions in this chapter. The first one is using the energy generated from chemical reactions to generate electricity, which is a working principle for chemical cell. So in this chapter, we're going to learn the second type of reaction, is that we use electricity to make those reactions that would normally not happen under room temperature to take place. Okay, so to do electrolysis, it must fulfill two requirements. So first, we can only do electrolysis for ionic substance. And secondly, the compound needs to be in either molten state or aqueous state. Okay, that's because it needs to be able to conduct electricity in order to let the electron flow through. The comparison between these two types of cells, we're going to come back after we finish learning electrolytic cell. So let's move on to page 3 first. Actually, you've come across electrolysis in grade 10. In Unit 10, we learned to use different methods to extract metals. For example, for those unreacted metals, we can simply use physical methods to extract it. For some more reactive metals, we can use reducing agent like carbon or hydrogen gas or carbon monoxide to reduce it. And for those very reactive metals, none of the methods mentioned before would work. So we must use electrolysis to extract those very reactive metals. Here is a diagram showing the electrolysis of molten lead to bromide to extract lead metal. So this is a simple case for electrolysis because the electrolyte here is in molten state. That means it only have two kinds of ions in it. The cation, which is Pb2 plus here, and the anion, which is a Br minus here. As we learned in Unit 20, halide ion, such as Br minus, it turns to lose electron and become bromine. Okay, and because it carries a negative charge, so when the circuit is completed, it's gonna be attracted to the positive electron. So we can fill in the equation as a positive electron first. So at the positive electron, bromide ions are attracted to it, and they lose electron. And we can write a half equation to represent this reaction. So bromide ion would turn back into bromine. Remember to balance the number of atoms by adding a 2, and then we also need to balance the charge, so we need 2 electrons on the right hand side. And lastly, don't forget the state symbol, because they are in molten state, so we should write L for liquid instead of AQ. Okay, there is no solvent in it, remember, so it's just L. Okay, and since it's lose electrons, so it undergo reduction, hence it can also be called the cathode in this cell. Okay, so we've finished discussing what's happening on the positive electron, and we can use the same principle to work out what's happening at the negative electron. Since a lead-2 ion carries a positive charge, it would be attracted to the negative electron, and as a negative electron, it's gonna gain electron. Again, if we write the equation, it would be like this. So lead-2 ion become lead metal, And remember, to balance the charge, we need 2 electrons on the left-hand side. And finally, add the state symbol in molten state, so we write L. So lead-2 ion it gains electron and undergo oxidation, so we can also call it the anode. So that's a very straightforward explanation for this simple electrolytic cell. However, we're gonna learn 5 more complex cases in this unit. They are listed on the next page. Okay, these 5 cases, by the end of this unit, you will be able to analyze it and explain how we get those products and how you reach your answers like that. Just like when we learned to compare the strength of intermolecular forces, we have to consider several factors, and they are listed in order that we must follow when we compare their intermolecular forces. In this unit, we also need to consider several factors. Okay, there are 3 factors you need to consider. One is their position on the electrochemical series, and the second one is the concentration of ions. So in this unit, you just need to focus on the concentration of the halide ion. And the third factor that you need to consider is the nature of electrodes. Are you using the inner electrode like carbon, or are you using something else like a metal, for example silver or copper as the electrode to do electrolysis? But bear in mind, these 3 factors are not placed in the order that we need to consider them. How we're going to analyze an electrolytic cell, the steps are listed on page 5. Okay, so whenever you are given a scenario of an electrolytic cell, you must write out all the mobile ions in the electrolyte first. Okay, remember, in this unit, you're gonna learn the electrolytic cell using aqueous solution. So not only the compound will dissociate to form ions, but water also gonna dissociate. So you will have H plus and OH minus as well. Okay, we're gonna talk about that in detail later. And then the second step, we need to consider the first factor. Do we have a high concentration of halide ion exist in the electrolyte? Okay, if we don't have any halide ion, for example, the Cl minus in the electrolyte, remember it must be in high concentration, then we can skip step 2 and move on to step 3. So in step 3, we need to consider, are we using inner electrode or metal as the electrode? So basically, we need to consider the materials, especially for the anode. Okay, and if we're using the inner electrode, then it's easier for us. Then we skip step 3 and move on to step 4. If there's no special case exist, then we just need to compare the position on the electrochemical series to decide which one gonna be oxidized and reduced. Okay, so how to apply these 4 steps, we're gonna explain in detail in the coming examples. Okay, so the first case, we're gonna look at the electrolysis of acidified water. So in this case, the electrolyte is dilute sulfuric acid and water. Remember last year we said water will be able to dissociate to form H plus and OH minus. So in the first step, we need to list out all the ions, and water as an electrolyte will be able to provide H plus and then OH minus for us. Okay, and then we need to consider dilute sulfuric acid. When it dissolves in water, it will also provide H plus and then sulfate ion, so we need to add that as well. Okay, then we need to consider the second factor. Do we have a high concentration of the halide ion in the electrolyte? So in these simple cases, we don't have any halide ion, so we just simply answer no and skip step 2. And then for the next factor, we're going to consider, do we use inner electrode, either carbon or platinum, or the metal as electrode? So as you can see, it labeled on the diagram. Here we're using inner electrode. Okay, so we can simply answer no and skip step 3. Okay, so next we're gonna discuss which one gonna be attracted to which electrode, and then we need to consider, according to the position of the electrochemical series, which one gonna be discharged first. Okay, so on the positive electrode, the negative ion, the anion, should be attracted to here. So both OH minus and SO4 2 minus will be attracted. And then which one gonna be discharged first? Later we're gonna use this table to help us decide. On the other side, the negative electrode, only H plus would be attracted, so H plus gonna be the one that will be discharged. Okay, so how do we know OH minus or SO4 2 minus gonna be discharged here? So this is a section of the electrochemical series. Okay, and we know as we go up from this table, the reducing power increase. Okay, so the stronger reducing agent will be oxidized first. Okay, so in this case, the OH minus will be oxidized instead of the SO4 2 minus. Okay, so we can write that down. Okay, so now we've completed the 4 steps required, and then we can use those information we get to fill in the left hand side. Okay, so at the negative electrode, we know H plus is discharged to form H2, hydrogen gas. Okay, and the half equation will be H plus turn into H2, hydrogen gas. Okay, remember to balance the total number of atoms and balance the charge. And finally, add the state symbol. Okay, so in this case, H plus is going to be in AQ, and then hydrogen gas produced will be in gas state. So H plus gain electron in the ion-Gauss reduction, so we call this the cathode. And on the positive electrode, the OH minus is preferentially discharged to form oxygen gas. Okay, and the reason is that on the electrochemical series, it shows us that OH minus is a stronger reducing agent than sulfate ion. Okay, so it would be discharged first. And the half equation to represent the reaction at the positive electrode would be OH minus turn into O2. Okay, so how to balance this equation is a bit trickier, so please turn to the learning diary and I will show you how to balance this equation. So previously we know we have OH minus as the reactant, and it would turn into O2 in the end. And using the previous method we have learned, we need to add water to balance the oxygen atom. So on the left hand side, we meant to add one water molecule so that the oxygen is balanced. The total number of oxygen atoms is balanced. Now we have 3 hydrogen atoms on the left hand side. Okay, so in order to balance that, we need to add 3 H plus on the right hand side. And finally, we need to consider the charge. On the left hand side, there's 1 minus on the left hand side. On the right hand side, total 3 plus. So to balance the charge, we need to have 4 electrons on the right hand side. Okay, but now remember we are at the positive electrode, so only the negative ions will be attracted to the positive electrode. So hence here the H plus will not exist. Okay, so in order to get rid of this H plus, we need to add OH minus on both sides, because there are a lot of OH minus around the positive electrode, and so the H plus will become water as a solvent. Okay, so on the right hand side we add 3 OH minus, on the left hand side we also add 3 OH minus, and will give us the overall equation, which will be 4 OH minus plus H2O, and then 4 electrons on the right hand side, oxygen on the right hand side, and then 3 water on the right hand side. And then lastly, we just need to cancel out the excess water. Okay, so the left hand side, the water will disappear, and the right hand side will be left with 2 water. So the equation will then turn into the one that we want, 4 OH minus turn to O2 plus 2 water plus 4 electrons. Okay, so that's the equation that we want. So we can copy this equation and paste it back to the place that we want. Okay, or we just simply complete this one. Okay, so it would be 2H2O plus 4 electrons. And remember, we need to add the state symbol. OH minus is in aqueous state. The oxygen gas produced is in gas state for sure, and water liquid state. Okay, so in order to get the overall equation, we just need to add the 2 half equation. Okay, this one and this one. Okay, so combine the 2 equation. Okay, remember the first one, the first half equation happening at the negative electrode, it only gains 2 electrons. However, the one at positive electron, it loses 4 electrons. To balance this equation must add times 2, okay, to get the overall equation. Okay, so the overall equation would be 2 water, and then we give you hydrogen gas and oxygen gas. Okay, so when we add H plus with OH minus, they're gonna combine to form water, so the overall equation we just use water to represent. Okay, and I missed this part. At the positive electron, at the positive electron, because it's losing electron, so it undergoes oxidation, so it's the anode. So now take a look at the overall equation here. Okay, and then take a look at the diagram. Would you be able to tell me which side is the positive electrode, which side is the negative electrode? Okay, remember to consider the volume of the 2 gases produced here. Okay, that's a hint for you. Okay, so as you can see, the ratio between the hydrogen gas produced and the oxygen gas produced is 2 to 1. That means when we have two water molecules, it's going to produce two hydrogen gas and one oxygen gas only. So the later we're going to learn, but the volume is proportional to its coefficient. So we will be able to label the two gases here. So the gas B should be the hydrogen gas and gas A should be the oxygen gas. Okay, and the reason is that the volume between hydrogen gas and the volume between oxygen gas should match with their mole ratio, which is 2 to 1. Okay. And what are we going to see on the electrolyte? What are the changes we will be able to observe? As you can see, during the electrolysis, water are constantly used to generate hydrogen gas and oxygen gas, but the dilute sulfuric acid is not used. Okay, so we are reducing the total amount of the solvent, but the solute remain the same. So we could conclude first, the concentration of the sulfuric acid would increase. Okay, so that's because we used up water, which is a solution, which is a solvent, but we did not use any of the dilute sulfuric acid in the electrolyte. And secondly, the total volume of the electrolyte gonna decrease. Okay. Okay, so that's a change on the electrolyte. And here is a question I want to leave for you. What would you expect to see the pH to would you expect the pH to go up or to go down? Okay, so a hint is that you should link to the concentration of the sulfuric acid and consider how we calculate pH in grade 10. Okay,